Jai Guru, I am Nitu Singh, lecturer YSM Ranchi, intermediate section. I am going to explain about solid state and its classification. Students, we know solids very well. We know that intermolecular force of attraction among solid particles is very high, and due to this solids are non-compressible, rigid and hard. Its volumes and shapes are definite. Now, classification of solids. There are two basic types of solids, amorphous solids and crystalline solids. I will explain both types of solids one by one. Amorphous solids. In amorphous solids, constituent particles do not arrange in definite order or may be arranged in short range order. Amorphous solids are isotropic. Here a question is arise, what is isotropic? The answer is amorphous solids have same physical properties in all directions. Actually, here the particles are randomly arranged and disordered, due to which all the directions are equivalent. Hence, all the properties remain same in all the directions. These types of solids do not possess definite geometry and sharp melting point. Crystalline solids. In crystalline solids, constituent particles arrange in definite order. As a result, the crystalline solids have definite shape, geometry, and sharp melting point. Crystalline solids are anisotropic, that is, do not have same physical properties in all the direction. On the basis of nature of bonding, the crystalline solids have been classified into four types: ionic crystals, molecular crystals, covalent crystals, and metallic crystals. Let's discuss about ionic crystals. Ionic crystals have positive and negative ions as constituent particles, which are bonded together by strong electrostatic forces of attraction. Now, molecular crystals. In molecular crystals, constituent particles are molecules which are bonded by van der Waals force. Example, dry form of water, that is ice, and also dry ice. What is dry ice? Solid form of carbon dioxide. A question is arise, why ice is an example of molecular crystals? Answer is because water is a molecule. Covalent crystals. It also known as network crystals. Generally, constituent particles are atoms, in some solids molecules also. Such solids are very hard and brittle because of the presence of strong and directional covalent bonds which hold the constituent particles very strongly at their position. Metallic crystals. Metallic crystals have positive metals ions and free electrons as constituent particles and bonded with metallic bonds. Example, all metals and its alloy. With this slide, I am discussing about inner classification of molecular crystals. Molecular crystals are further divided into three categories: non-polar, polar, and hydrogen bonded. In non-polar molecular crystals, constituent particles are non-polar in nature and bonded by weak dispersion force. Weak dispersion force is also known as London force. This is very important for objective questions. Now, polar. In polar molecular crystals, constituent particles are polar in nature and bonded by dipole-dipole interactions. Its melting point always higher than non-polar molecular solids. Hydrogen bonded molecular solids. Hydrogen bonded molecular solids are those in which the molecules contain polar covalent bonds between hydrogen and high electronegative elements such as fluorine, oxygen and nitrogen. I would like to summarize the topic with some new terms and important questions. There are two new terms, isotropic and anisotropic, which have been explained, and two questions for your examinations. Please solve it. Continue with attempts of learning and practice to write. Thank you.